Everyone, and welcome to my channel Maths with Lacy B. In this video, we'll be discussing a question of JEE Advanced, which is from the topic of permutation and combinations. So the question says that you have 6x, this 6x's. Okay, the letter x is 6 times, and you have to place these x in this figure, in each square, such that each row has at least one x. So this is row 1, this is row 2, this is row 3. So each row should have at least one x. So in how many different ways can this be done? You have to place these x's in the squares such that each row should have at least one x. So in how many ways can you do this? So first of all, what is an incorrect method of doing this question? So incorrect method is that you choose one position out of the two for row 1, one position out of the 4 for row 2, and one position out of the 2 positions for your row 3. So this means choosing one position means you are filling the x in that square, and this means your 3 x's are already filled and 3 remain. And how many positions are left, or how many squares are left? Since 3 squares are occupied already, and you have in total 1, 2, 8 squares you have in total. So, and 3 are occupied, that means you have 5 left, and out of those 5 you choose 3 because you have to place your remaining 3 x's, and you calculate using this method. So let me tell you, this is a very incorrect method of solving this question, because if you choose, for example, you choose this position for R1, you choose this position for R2, and you choose this position for your R3. You place your x's. Now, you have to fill 3 more squares with the x's. So, what do? You then select this position, this square, and this square. Okay. So, this is one method which is included in this calculation. Now, if you now initially, if you choose this square, and this square, you place your x, and then you choose this square, you choose this square, and you choose this square according to this 5c3, and you place your x. So is there any difference? I have colored x with, I have used different colors for these x, but actually color doesn't matter because the letter is the same. So this pattern and this pattern has no difference. This is same actually. But this calculation will consider this as distinct and will take it as 2. Are you understanding what I'm saying? First you chose 3 positions here like this, and to fill your rest 3 x's, you chose your 3 positions like this. Then you chose your first 3 positions from each row like this using purple x. The positions that I have denoted using purple color, and the rest 3x you fill like this. But either you do this way or you do this way, there's no difference. You're ending up with the same pattern. That means this calculation takes or gives you duplicacies. There will be duplicate ways. So this method is highly incorrect. So what is the correct method? I have already mentioned this in my previous video on some topic of permutation and combination, that it is always a good practice to take cases. you'll be able to make your life easy, very easy, if you will be taking cases. So let us discuss now the correct method of solving this question. Okay. So your case 1 is that your R2 is full. Your case 2 is R1 and R3 are full. And your case 3 is your R2 has 3x. So can there be any other case? Can there be any other case? See, you have only 6 x's. Okay. Now one way is to fill your R1 and R3 completely. So your 4 x's are already taken and you have 2 x's which you will be remaining, which you will be filling in the R2 row. Okay. Or the one other case is that your R2 is full. That means you have placed your 4x in the row R2 and the remaining 2 will be filled in row 1 and row 3. Okay. And the case 3 is that R2 has 3 x's. R2 has 3 x's and the rest 3 will be filled in R1 and R3. But can there be any other case? So there cannot be any other case because you cannot, if you think of filling only 2 x's in row R2, then you will have then you will have 4 x's remaining. Then this would just mean that this case R1 or R3 are full. Okay, this will come to this case only. It is good to do it this way. R4 has all 4 filled. R2. R2 has all 4 filled. R2 has 3 filled, which is this case. R2 has 2 filled, which is this case. R1, R3 are full. And R2 has only 1 filled. Now, is it possible? Is this case possible that R2 has only 1 filled? Then that means that 5 other x's will be placed in row 1 and row 3, which have only 4 squares. And to fill the 5 x's, you need 5 squares. So this case that R2 has only 1 x in any of the square, so this case is not possible. So you have only 3 cases. And of course, if R2 cannot have 1, then of course R2 cannot have 0 because you need at least 1 x in each row. And of course, if you will not be having any x in the R2, then all the 6 x's will be going in R1 and R3, which is not possible because you have only 4 total squares or boxes in R1 and R3. So that means these are the only cases. So we just need to do the calculation to find out the final answer. Okay, so to find out the final answer, that means R2 is full. So we consider the case that R2 is full. So you have 2 x's remaining, which you have to fill in R1 and R3. Now, every row should have at least 1. That means out of 2 from R1, you have to select 1. And for R3 also, you have to select 1. So this gives you 4 ways. So the first case gives you 4 ways. Now case 2 is R1 and R3 both are full. So this means and you have 2x remaining. So you can fill this in the R2 row and you have 4 positions. So out of 4 positions, you have to select 2 to fill your remaining x's. So this gives you 6 ways. Okay, and now the very last case is that R2 has 3 x's. Now R2 has 3 x's. That means to fill your R2 with 3 x's, you first have to choose 3 squares out of the 4 squares, because you have 4 squares in R2 and you have to just fill 3 out of the 4. So 4C3. So that you can choose your 3 squares out of those 4 squares where you will be substituting your x. Now the rest 3, you have now 3 x's remaining because R2 has already taken 3 x's, and those rest 3 x's you have to fill in R1 and R3. So you have in total 4 positions. Total 4 positions, including your R1 and R3. Now, out of those 4, you have to choose 3. So, this gives you 4 into 4, which is 16. Okay, and one more thing. Here you chose the 3 positions from R1 and R3. You had 4 positions and you choose 3 positions for your case 3. So, this guarantees that one will be there from each row, at least one, because either you choose this or you choose it like this. Since there are 4 positions and 2 are there in each row, so that means one will be occupied. One will be taken, one square will be taken from each row, and the third one can be taken from any of the rows. But in the case 1, what I asked you to do, that you have to do it 2C1 into 2C1. So you could not do it like you have 4 positions and you had to choose 2 for your R1 and R3. So you could do 4. You could do 4C2. So this would have been incorrect, because if you just choose 4C2, that means out of 4 positions you choose 2, then it might have been possible that you had chosen this x and this way. So this would have been wrong, because consider or be careful that you have to fill at least one x in each row. So if you had done 4C2 to choose the 2 squares out of those 4 squares from R1 and R3, then it would have been wrong, because if it is like x and x from R3, then R1 would have been remained empty, which is not possible. So these are the total ways, which is 4 plus 6 plus 16, which gives you 26 ways. So thank you so much for watching this video, and happy learning. See you in the next video.